Hello, this is Mr. Wyrick. I'm here to talk to you about lesson 11.5, the fifth lesson of chapter 11 and the last lesson of chapter 11. Chapter 11 has been covering area of different polygons, so this is still going to be area, except this is going to be areas of similar figures. What we have here is a couple of trapezoids. They're not the usual isosceles trapezoids that you're probably used to looking at, but these are a couple of trapezoids and they are similar in shape. If you remember similar, it means we have the same angles in the same locations, and the sizes of the side are in proportion. So if this one were 5, this one would be 10. This were 5, this would also be 10. This one we could call 8, so we'd say this is 16. And then we'd call this one, I guess, 7, so this would be 7. No, sorry, this would be 14. So what we're dealing with here is we have similar figures. And in the book, it's theorem 11.1. It says if we have similar figures, then if ABCD is similar to FGHJ, ABCD, FGH, oh, sorry, I've got the C and D backwards here. ABCD to FGHJ, if they are similar, then the areas are similar, but it is the side proportion squared. It goes on to give a few different examples of that, but it doesn't really expand on it any. And what I'd like to do is introduce a different way, kind of a looking at that. I'm just going to put a big OR right here. Here it is, P, A, V, 1, 2, 3. Okay, so if you have similar figures, then the perimeters have a 1-to-1 at that exact same ratio. So if this side is 5 and this side is 10, then this one is double the size of this one. So the perimeter would also be double. Okay, everything's going to add up. The perimeter is going to be double. The area going from this one to this one, instead of being just double, would be that to the second degree. So that would be times 4. And if we had a 3-dimensional shape here, if we were doing volume, it would be to the 3rd power, which means it would be 8. All right. Basically, what you're going to have to do on this one is one of two things. If they tell you the ratio, you're going to have to either convert the side down to the side with every single ratio and go ahead and find the area, or you're going to have to take that ratio, square it, and then find the area of the new one. Or if they give you the areas of them and ask you to find what the ratio of the sides would be, you'll have to really pay attention about which direction they are asking you to move, large to small or small to large. Remember, that makes a difference. And then you would find the square root of that if you're given the areas of those and you're asked to go down and find the sides. That's pretty much all there is to talk about this one. It can be a little complex, so make sure you take a look at some of the examples. You see what's going on there. You might take one down in your notes just to be on the safe side. For this one, because there's not a ton of concepts, there's going to be a few more problems that we do. So we're going to go through 26. They don't have a lot of examples, but we're going to start on 6 and go all the way through 26 for this lesson. If you have any questions about this one, if it doesn't make sense the way I explained it, if you don't really get this, remember these are degrees, not just multipliers. Come in and ask me, or raise your hand during class, come in tutorials, whatever it is that you need to do to get a better understanding of what's going on, and we'll see you then.